The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The broadcast is now starting. All attendees are in listen-only mode.
Guys, please confirm to me. All of you get my voice on screen. Those are attending in online. Guys, please confirm to me. All of you get my voice on screen. Those are attending in online. Guys, please confirm to me. All of you get my voice on screen. Shiva. Shiva. Guys, please confirm to me. All of you get my voice on screen. Those are attending in online. The Oracle confirm chesara 6:30. So confirm chesna cheptan class lo chesna. All of you get my voice on screen. Those are attending in online. Confirm to me. All of you get my voice on screen. Those are attending in online. All right, sir. And along with this core Java, very soon, Oracle batch is going to be start for the package students. I think so. Maybe at 6:30 to 7:30 for this class continuation part. You are able to have Oracle classes there. So try to plan for it, but not immediately. All right. Then after a few days of time, we are going to have classes. Okay. Don't worry for it. Maybe then within 10 days of time max, you are able to have that Oracle class. Those who are in packages. Official intimation we are able to get, but it was discussed there, almost all finalized. For completion of your class, immediately you are going to have what there Oracle classes that we have planned. Okay. After that, after a few days of time, again UI classes are going to be started. And those who are in packages, those who are in full stack Java, immediately wherever, that means immediately at Durga Soft, when the batches are started for DevOps, they can plan for the DevOps immediately. Okay, at morning I think so batches are starting there for DevOps there. Then try to check with our office there. Then they will give some intimation to regarding the date and the time. Demo classes there. Just try to attend for the DevOps classes also. Those are in full stack Java. Don't neglect this kind of courses. If you take the courses parallelly, 3 to 4 courses parallelly, then only you are able to complete your total syllabus continuously. In a less time, we are able to complete it. Okay. All right. Then 4 o'clock to up to 6:30, or maybe 3:30 to 6:30, maybe in the future, but not immediately. I'll plan for it. But as of now, 4 to 6:30, I'm telling that is totally my time. I will take that. For Java, I'm going to assign 2 slots are required for Java. Okay. So in the middle of the core Java, I'm going to start advanced Java. When core Java is completed, when we are in middle of advanced Java, I'll start frameworks. So I have a clear-cut path for it. I'm going to take it 2 slots. I'm going to take for the sake of these courses there. Remaining slots we can utilize for other courses now. Okay. Right. Leave this one. So now we already understood the content here. Then what topics here we are discussing there? Introductory classes here we are understanding. Then a part of it, differences between Java and others. The topic also here we started in the differences between Java and others. There almost all 2 to 3 differences we completed. I think third difference here we are understanding. All right. Now before that, now tell me what differences we completed there in the differences between Java and others. The first one is what? C and C++ are static programming languages, but Java is what? A dynamic programming language. Point number one. Next one is, what is the next point here? Preprocessor is required in C and C++, but preprocessor does not required in Java. That is the second point. That's okay, fine. Now, the third point here we are going to understand, we are understanding here. What was the third point here we are getting? C and C++ are platform dependent programming languages, but Java is a platform independent programming language. Where about C and C++ we completed the discussion, but the pending point is what there about the Java. How Java is a platform independent, that point here we have to understand. Right, so now first of all tell me, if any programming language allows its applications to perform the compilation and the execution on the same operating system, mandatory, must use the same operating system for compilation and execution, then that programming language is called platform dependent programming language. That programming language is called what there? Platform dependent programming language. Examples for platform dependent programming languages are C and C++. Got it clear? All of you are getting clarity on it? C and C++. Okay, fine. Next one is after completion of this point here, another, right, example here are given, some discussion here are given there. Observe carefully. If you compile C program on Windows operating system, automatically .exe file here we are getting. What this .exe file contains actually? .exe file contains directly executable code, and it is having the local operating system representations like Windows operating system representations. Remember it, from one operating system to another operating system, internal data representations are varied. We are not going to have the same representations in all the operating systems. Windows is having one type of representation, Linux is having another type of representation, Unix is having another type of representation, Mac has some other type of representation. And all the operating systems, different representations are going on. Understand it clearly. Now, the point here, what I am telling to you, when we compile our C program on Windows operating system, a .exe file will be generated, which has the directly executable code, and it must have the local operating system representations. That is Windows operating system representations. If we want to execute this Windows represented .exe file, we must have the same Windows operating system at a runtime. Not possible to execute Windows represented .exe file in other operating systems. That is the reason why in C and C++, execution operating system is dependent on the operating system which we use for compilation. So that C and C++ programming languages are dependent on the operating systems. So that's why C and C++ are what their platform dependent programming languages. Right. Now let me have some description, that means text data related to this particular point here. Understand it now? If we compile C and C++ applications or programs, then the compiler will generate .exe files. Compiler will generate .exe file, where the .exe file contains directly executable file, directly executable codes, and it is having the local operating system representations like what there? Windows operating system representations. Right, Windows operating system representations. Right, observe carefully. In the above context, if you want to execute Windows represented .exe file, in the above context, if you want to execute the Windows represented .exe file, then we must provide the same Windows representations, the same Windows operating system at runtime. Here the C program, the C program execution, C and C++ programs execution is dependent on the operating system which we used for the compilation. So C and C++ are the platform dependent programming languages. So C and C++ are the platform dependent programming languages. That's it. In the above context, if you want to execute the Windows represented.exe file, then we must provide the same Windows operating system at runtime. Here the C and C++ programs execution is dependent on the operating system which we used for the compilation. So C and C++ are what their platform dependent programming languages. Before that, I have given the point. If we compile C and C++ applications, then the compiler will generate a .exe file where the .exe file contains directly executable code, and it is having the local operating system representations like Windows operating system representations. In the above context, if we want to execute the Windows represented.exe file, then we must provide the same Windows operating system at runtime. Here, the C and C++ programs execution is dependent on the operating system which we used for the compilation. So C and C++ are the platform dependent program languages. That's okay, fine. Right, now it is completed. Observe carefully. The related diagram also we are given. Okay. All right, up to now it's okay, fine. This is about like what there, C and C++. All of you are getting it now? But here my requirement is what there, Java. About this Java, how can you say that Java is a platform independent programming language? First of all, tell me, what is platform independent programming language? What is platform independent programming language? What we are understanding about it, platform independent programming language, is quite opposite of the platform dependent programming languages. Is totally opposite of the platform dependent programming languages. Tell me, what is it actually? If any programming language allows its applications to perform the compilation in one operating system, and the execution is in the another operating system, then the programming language is called a platform independent programming language. That's not tell me all of you know. If any programming language allows its applications to perform the compilation in one operating system and the execution is in another operating system, then the programming language is called a platform independent programming language. Example here I'm telling to you, Java, of course Python, .NET and so on. But now our intention is what they're totally Java. So let us understand clearly about this Java, how Java is platform independent programming language. Right, so then your complete attention is required to understand this Java and its platform independent nature. With a small minute point, we are going to understand Java and its platform independent nature content. Everybody put more concentration here now. Right. Now observe carefully, all of you know. Right, sir. First of all, I want to take a Java program. Right, sir. This is my Java program. So .java file. Extension must be what there? .java. Clear. The next one is I want to perform compilation. Compilation I want to perform. This is compilation, what we performed here. Compilation. When we perform compilation over a Java program, here we are able to have a dot class file, already this bunch. What file here we are able to get there? Dot class file. Okay. In the dot class file, some code is available. What is that code? I will discuss with you clearly later on. Then my intention is what there? If we compile Java program on one operating system and we can execute the same program in other operating systems. As per the definition, I want to prepare a diagram. After that, I will give explanation clearly. Now, what I'm telling now, after completion of this, 1 minute. Okay. Now, I want to execute this program. How many times execution care I want to provide there? Observe carefully. Multiple executions care I want to provide. What are these multiple executions care now? One time, okay, this is one operating system. Here we are able to have outputs. Execution. Output here we are able to have. Like this, multiple times. Sorry. Multiple times I want to perform this execution. This is second execution. This is third one. This is like what there, the fourth one. Overall, 4 times we want to execute this program. Now tell me here, how many times here we compiled our program there? How many times we compiled our program? Only 1 time. But how many times we are executing our program? 4 times. Observe carefully. Okay, fine. Now observe carefully. 1 time we are performing compilation and 4 times we are executing the same program. Now I want to provide the operating systems now. Everybody understand it now? I want to perform compilation is on what there? Windows. One-time execution, I want to provide like what there, Linux. Another time I want to provide something else like what there. All right, sir, Linux is okay, fine. The next one is what there, Unix, for example. Or else maybe I want to provide some other time like what there, Solaris. Is it Solaris or Solaris? No. Okay, order it maybe, don't worry. Operating system, Solaris, right? Sun Microsystems product previously. Next one is what there, Mac. Understand it? That last, another one is like I'm going to use the same Windows, no problem. Of course, we can use what there, the same Windows. Now see this diagram here, what we are understanding there. How many times we are performing compilation? Come on. How many times we perform compilation? Only one time. One time we are performing compilation, but how many times we are executing our program? 4 times. Compilation is going on which operating system? Windows. But in how many operating systems? On which operating systems we are executing our program? On Linux, Solaris, Mac, and again the same Windows operating system. That means compilation is going on in one operating system, but execution is going on in what there? Another operating systems. If it is going on, if it is as it is going on, in the case of Java program, then Java is what there? Platform independent programming language. Yes, it's possible the same thing is going to happen in the case of Java. The same thing is going on in the case of Java. That's why Java is what there? Platform independent programming language. But here my question is what there? How it is possible to run the same program on multiple operating systems? How it is possible? What exactly the internal concept why the Java is a platform independent programming language? I'll give some clarity. Now try to understand these points now. All of you observe carefully. First of all, what I am telling now, when we compile Java program and Windows operating system, here we are getting what there dot class file here we are getting. Nice. What is this dot class file? Let us understand it. What exactly the meaning of dot class file here? Observe carefully. Dot class file contains bytecode. All of you recognize this. Dot class file contains what code here? Bytecode. .exe file contains directly executable code, but dot class file contains bytecode. It is not directly executable code. It is not directly executable code. It is an intermediate code. It is not directly executable code. It is what there? An intermediate code. Yes, sir. All of you are getting it or not? It is what there? An intermediate code. And it is not having the local operating system representations, including Windows representations. All of you observe carefully what exactly the points here we are understanding there. Now the point like what I am telling to you, observe carefully. This is dot class file contains a bytecode. It is not directly executable code. It is an intermediate code and it is not having the local operating system representations. This is what exactly the meaning of what their dot class file. Clear? Right, sir. It's okay. Some information about this dot class file here we are getting. Okay, right, good. It doesn't have any operating system representations. It is an intermediate code. It's a neutral bytecode. But here the problem is what? If you want to run any bytecode, or if you want to run any .class file under Linux operating system, that bytecode must have Linux operating system representations. If you want to run any code under Linux operating system, that bytecode must have which representations? No, Linux representation. That bytecode must be in Linux formations. If you want to run any code on Solaris operating system, that bytecode must have Solaris representations. If you want to run any bytecode on Mac operating system, that bytecode must have Mac representations. If you want to run any bytecode on Windows operating system, that bytecode must have Windows representations. But what bytecode here we provided here? After compilation of our program, what bytecode here we are getting? We are getting the bytecode is like what there? A neutral bytecode. Even it is not having Windows representations. No operating system specific bytecode is available. It is an intermediate code, not directly executable code, not directly operating system represented bytecode. It is a neutral and intermediate bytecode we are having. But if you want to run this bytecode on Linux, it must have Linux representations, but it doesn't have Linux representations. If you want to run this bytecode on Solaris, it must have Solaris representations, but it doesn't include Solaris representations. If you want to run this bytecode on Mac, it must have Mac, but it doesn't have Mac representations. If you want to execute this on Windows, it must have Windows representations, but it doesn't have Windows representations. All of you get my point or not? Clear? All of you are getting clarity on this? Now the point here, what I am telling there, now here we are getting a problem. The bytecode is neutral bytecode, but to execute that, it must have the respective operating system representations now. So here almost a similar problem what we have seen in the case of C and C++, almost the similar problem here we are getting. Got it or not? Exactly in this particular situation, C programming language vendor has not provided any solution, but Java programming language vendor, Sun Microsystems, has provided solution. What solution that Sun Microsystems has given there? Just analyze this. Analyze the point here. What Sun Microsystems has given the solution here? Sun Microsystems has provided converters to convert the bytecode from neutral nature to the respective operating system representations. To make Java is a platform independent programming language, in this particular situation, Sun Microsystems has provided some translators or some converters. I get my point or not? Where the converters are provided, exactly where we are going to use that converters. If you observe this point here, answer is very clear. Understand it? No? Exactly here the converters are required. Exactly in this case, no, the converters are required. Observe carefully. Here we required one converter. Here we need another converter. Here we need another converter. Similarly, here we required another converter. All of you observe carefully. Now here, this is like what I am telling to you. The converters here we required. This is one converter. Another converter. This is another converter, or maybe translator. We can use any name, no issues for it. Now tell me, what is the job of this particular converter? The job of this particular converter is, it will take a neutral bytecode as an input, and it is able to convert that neutral bytecode into Linux representations. Got my point or not? A bytecode with the Linux representation, that means with a particular operating system representations, that bytecode is called a native code. That bytecode is called as what there? A native code. Understand my point here? What is the job of this converter? No, this converter will convert a neutral bytecode into its local operating system representations. A bytecode with the operating system representations. A bytecode is in operating system representation, that is called as what there? Native code. What is that native code? Now tell me. Native code is a bytecode plus a operating system representations. Bytecode is a neutral code. But when we provide this operating system representations to that bytecode, then that code is what their native code. Native code is directly executable code. Now, in this case, what happened? Converter is converting that bytecode to the native code. If we give that native code to this execution, automatically execution is going to be performed over this code. There we are able to get some output. Similarly, now tell me, what is the job of this particular converter? The job of this particular converter is it is able to take that neutral bytecode as an input and it is able to convert that neutral bytecode to what representations? No, Solaris representation. Now bytecode with operating system representations are coming or not? And a bytecode with operating system representations if we are getting, now that bytecode is nothing but what their native code. If we provide this native code to this execution is going to be performed over this native code and here we are able to get the outputs directly. Leave this one. Similarly, what is the job of this particular converter? Now tell me. The job of this particular converter is it is able to take that neutral bytecode as an input and convert that neutral bytecode to the MAC representations. Convert that bytecode to what representations there? MAC representations. Everybody understand it clearly. Whenever we are converting that bytecode to the MAC representations, that MAC represented bytecode is nothing but what here is a native code. That native code here we are able to have like this. Similarly, next one is, what is the job of this particular converter, sir? Now tell me. This converter is able to take neutral bytecode and converting that neutral bytecode to what their Windows representations. But understand the magic here. For compilation, we have used Windows. For execution also, we are using Windows. But in the case of Java, still conversion is required. Yes, sir, got my point or not? In C and C++, if we use Windows operating system for compilation and execution, nothing is required. Directly program will be executed. But in the case of Java, even if we use Windows operating system for both compilation and execution, but still conversion is required to convert that bytecode from neutral nature to the Windows representations. Got my point or not? Okay. Now the job of this converter is converting the neutral bytecode into the Windows representations. Now here also be a bytecode with Windows representations is called as like what their native code. Is called as like what their native code that we have to understand now. Right, sir? It's okay, fine. Now this is exactly the meaning of like what their native code and the respective converters. Hello, if you're getting it or not? All right. But how Sun Microsystems has provided these conversions? How Sun Microsystems has provided these conversions actually? If we observe this particular point now, I'm giving some clarity, observe carefully. Sun Microsystems has provided these conversions. Sun Microsystems has provided these conversions. Sun Microsystems has provided these conversions along with execution in the form of a separate device. Sun Microsystems has provided these conversions along with the execution process in a separate device, in a separate component. Here also be conversion and execution both will be provided in a separate component. Here also be conversion and execution both will be provided in a separate component. There also be conversion and execution both are going on in a separate component. Now here the name of this particular component is what exactly the name of this particular component here. If you observe this, understand this point no. The name of this component is like what there? JVM. The name of that particular component is what there? JVM. Understand it clearly. All right, sir. Right, sir. Now the name of this particular component is like what there? JVM. This is JVM. Again, this is JVM. JVM. This is also like what there? JVM. That's it. Now I'm asking this question to all of you. Now try to answer for it. Everybody. How many times we compiled our program here? Only one time we compiled our program. But how many times we executed our program? 4 times. 4 times we have used JVMs or not? 4 times we have used JVMs or not? Right. Now my question is, in this entire 4 times execution, how many JVMs here we have used? Is that only one JVM or 4 JVMs? Right. Think and give the answer here. 1 JVM or 4 JVMs? No. Right. Now the answer is what? 4 JVMs, not 1 JVM. 4 JVMs. Understand it? Now the answer is what there? 4 JVMs. Why the answer is 4 JVMs? No. Understand the conclusion. Java is a platform independent programming language because of JVMs only. Java is a platform independent programming language because of JVMs only. But JVM is a platform dependent tool. JVM is what there? Platform dependent tool. Java programming language is platform independent, but JVM is what there? Platform dependent tool. Now tell me, if it is a platform dependent tool, on Linux operating system, Linux based JVM is required. That means Solaris operating system, in the sense Solaris based JVM is required. Mac based JVM is required. Finally, Windows based JVM is required. Now tell me, all the JVMs are only 1 JVM or 4 JVMs? No, 4 JVMs. How can you say that 4 JVMs here? No. What exactly the reason here? No. Java is a platform independent programming language because of JVMs only. But JVM is what there? A platform dependent tool. JVM is a platform dependent tool. Got or not? Right, here 4 JVMs here we have used dependent on the operating systems. Okay, now let me have a small comment here over this code. No, what is the point here I'm telling here? JVM, I'll provide this first of all. What I'm going to give the point here about this JVM here, it is a platform dependent. Okay, fine. What is its responsibility actually? Its responsibilities are like what there? Conversion from bytecode to the native code. Conversion from bytecode to the native code. Next one is what there? Execution of the native code. Executing native code. These are exactly two responsibilities of like what there? JVM. What exactly the job of the JVM can now tell me? It's a platform dependent first point. Next one is two responsibilities. What are the two responsibilities? No, conversions from bytecode to the native code and execution of the native code. That's it. They're the two responsibilities of the JVM. Okay, fine. But still, I'm getting a question here. What exactly the question here I'm getting now? Okay, sir. We are saying that Java is a platform independent programming language, but JVM is a platform dependent. Okay, fine. But how can I get different JVMs here now? How it is possible to manage different JVMs? How can I identify I'm using Linux operating system? How can I get Linux based JVM? I'm using Windows operating system. How can I get Windows based JVM? Or I'm using Mac operating system. How can I go for like what the Mac based JVM? How can I say that the JVMs? How it is possible? All right. Now for that purpose, I'm giving clarity. Now try to understand it, all of you know. In this diagram itself, I'm giving explanation to you. Observe carefully. Now tell me, first of all, here we are performing compilation. Am I right or not? Okay. We are performing compilation on which operating system, you know? Windows operating system. Means that assume it, here we have a computer. In this computer, Windows operating system is available. And that Windows operating system, we prepared Java program, we are compiling that Java program. To perform compilation of the Java program, Java compiler is required or not? Means that Java software must be installed in this computer or not? So one computer, operating system, Windows operating system, over the top of this Windows operating system, Java software we have to install. On the top of the Java software only we are performing compilation. So in this computer, we have to install Java software, point number one. Now come for it. First execution we understood on Linux. On Linux, we are executing this program in the sense, understand it, this is also another computer. How many executions can we provided here? 4 times. 4 computers we have taken. In first computer, I have a Linux operating system. Over the top of it, Java software I installed over the Linux operating system. On the top of the Java software, I'm performing execution. To perform execution, JVM is required or not? The JVM will come along with Java software only. Means that the Java software here we have to install. Like this, how many executions? No, 4 executions, 4 computers, 4 different operating systems, 4 Java softwares we have to install. Over the top of these 4 Java softwares only, we are able to add 4 JVMs. That by using that 4 JVMs only, our program will be executed 4 times. Got or not? But still my question is what there? It's okay. Everything is okay. Different computers, different operating systems. I require different Java softwares now. But how I can get the JVM, Linux based JVM or Solaris based JVM, Mac JVM or Windows based JVM? That is my question now. Now there I am telling the point here. What is the point here we are missing up to know? The point is what? Java programming language is platform independent programming language because of JVMs only. But JVM is what there? Platform dependent tool. Not only JVM. Listen carefully. Not only JVM. The total Java software is platform dependent. Java software is different. Java programming language is different. Java program is different. What is Java software? Java software is a collection of the Java tools. What are the collection of the Java tools? No, Java compiler, JVM, Java profiler, Java debugger, and Java signer. Like this, 35 to 40 tools are available. Their combination is nothing but Java software. Their collective content is nothing but what their Java software. Got it or not? Installing Java software in the sense providing these 35 number of tools in our system. That's it. Installing Java software in a sense, providing these 30 to 35 number of tools in our system. That's the meaning of installation of the Java software. This entire Java software, that is the 35 number of tools are platform dependent. But Java programming language is what? Independent. Java program is what there? Independent. But Java software is what there? Dependent. Inside the Java software, Java compiler dependent, JVM dependent. All 35 to 40 number of tools are what there? Dependent. Yes, sir, got it or not? Okay. But still my question is, how I can get Windows based JVM, Linux based JVM, Solaris based JVM, Mac based JVM? Nothing, very simple. If we want to compile our Java program here, we require a Java software or not? First recognize what operating system here we have used Windows. Windows related Java software we have to download from internet. That Windows based JVM we have to install in our compilation system. Coming to this first execution mission here. In the first execution mission, what is available? Linux operating system. Recognize that Linux operating system. Go to the Oracle website. Download Linux based Java software only, not any other one. Install Linux based Java software on the Linux operating system. Then execute that program on Linux based Java software. If we install Linux based Java software here, Linux based JVM will come. If you install Windows based Java software here, Windows based Java compiler JVM will come. Understand it clearly. Next one is in the second execution, if you want to go there, Solaris operating system here we are using. Recognize this Solaris operating system. Download Solaris based Solaris based Java software from internet. Install Solaris based Java software in Solaris operating system. There where Solaris based JVM will come, use that to execute our Java program. When we want to execute on Mac, download and execute, download and install Mac based Java software and Mac operating system, where we are able to get Mac based JVM, Mac based compiler. By using Mac based JVM, we can execute that program here. Then we are able to get output. Similarly, what I'm telling there, no, next one is like what there, what I'm telling to you. Right, download and install what operating system related Java software? Windows based Java software. When we download and execute Windows based Java software, then what next one here we have to do there? Right, execute that Windows based Java software. Install that Windows based Java software. when we install Windows-based Java software, there we are able to get Windows-based compiler and Windows-based JVM. Use that Windows-based JVM to execute our program. That's finished. In this overall picture, what's the point I'm telling there? Java is a platform independent programming language because of JVMs only. But JVM is what there? Platform dependent. Not only JVM, the total Java software is what there? Platform dependent. That's it. What is Java software again? No, it is a combination of the Java tools like Java compiler, JVM, Java profiler, Java documentator, and so on and so on and so on. Nearly 35 to 40 tools are available. Yes, sir. Got it or not? So in this way, we can conclude that Java is what there? A platform independent programming language. Java is a platform independent programming language because of this particular reason only. Right, sir. Now I want to copy this total diagram here. Now let us come for the content here. Now I'll give explanation. No need to worry for it. The diagram here I provided. First of all, let me go for the explanation clearly. Text data here I'm going to provide for this. Now try to observe carefully. All right, sir. Now, if we compile a Java file, if we compile a Java file on the Windows operating system, then if we compile a Java file on the Windows operating system, then the compiler will generate a .class file. Compiler will generate a .class file, where the .class file contains bytecode, where the bytecode is not a directly executable code. It's an intermediate code, and it doesn't have the operating system, doesn't have the operating system representations. Fine. Right, sir. If we compile a Java file on the Windows operating system, then the compiler will generate a .class file, where the .class file contains bytecode, where the bytecode .class file contains bytecode, comma, it is not directly executable code. It is an intermediate code, and it doesn't have the operating system representations. Okay, fine. If we want to execute bytecode in any operating system, then the bytecode must have the operating system representations. All right, sir. If you want to execute the bytecode in any of the operating system, then the bytecode must have the operating system representations. Understand it clearly. All right. In this context, to make Java as a platform independent programming language and to execute bytecode in the different operating systems, Sun Microsystems has provided converters to convert the bytecode to the local operating system representations, that is native code. Does that understand it clearly? In this context, to make Java as a platform independent programming language and to execute bytecode in the different operating systems, Sun Microsystems has provided converters to convert the bytecode to the local operating system representations. That is what their native code. That's it. Now this is the total content here what we provided. Now the point here what I am telling here, the required information I have given about this total content here. First we are compiling on one operating system. There we are getting neutral bytecode that we converted by using converters, and the converted bytecode is nothing but native code. If we give that native code to the execution engine, it will execute the program directly there. We are able to get our output. That's the normal process. Already we understood that. Now I'm giving the conclusion. Observe carefully. In Java, the main, okay, fine. Now observe carefully. In the above context, Sun Microsystems has provided the converters along with the execution process in a separate component called JVM. What is that JVM actually? Java Virtual Machine. That's it. JVM. That's okay, fine. In the above context, Sun Microsystems has provided the converters along with the execution process in a separate component called JVM. A separate component, that is what there, JVM, Java Virtual Machine. That's okay, fine. In Java, the main role of the JVM is, number one, converting neutral bytecode to the local operating system representations, that is native code. That is what the native code. Converting in Java, the main role of the JVM is converting neutral bytecode to the local operating system representations, that is native code. Then after that, what next one can know? Executing the generated native code. Executing the generated native code. That's it. Now these are the two things here we have to understand. Two responsibilities are available. Converting neutral bytecode to the local operating system representations, that is native code, and executing the generated native code. That's we completed now. Now coming to the conclusion here now. Java is a platform independent programming language. Java is a platform independent programming language because of JVMs only. Because of JVMs only, but JVM is a platform dependent. JVM is a platform dependent tool. JVM is what a platform dependent tool. Right. Now I want to give a small note. What is that note actually? Not only JVM, the complete Java software is nothing but what a collection of Java tools like Java compiler, JVM, Java profiler, and so on and so on, some other. Right? Java software is platform dependent. That's it. But still, if you want to get some proof kind of thing, no, Java software is a platform dependent kind of proof. If you want to get it, no, I'll show one point here, try to understand it. Now, just I want to say like what the Java software downloads. So observe carefully. I want to download the Java software. Let me go with Oracle. Oracle here, I want to check it. No, try to understand it. Now let me open in a new tab. Java 21 and Java 17 both are available now. 21 version is also available. Okay, don't worry for it. In our classes up to 21st version, we are going to discuss there. All right, sir. Now observe carefully. The Java software is available now. Observe carefully. Windows, Mac, Linux. Am I right? If you take these are the Linux subversions. Mac, these many options are available. Windows, these many options are available. Downloadable links are provided. Think of it. If Java software is not platform dependent, yes, sir, are you getting this one? All right, sir. If Java software is not platform dependent, if it is platform independent, why these many versions are coming here? Why these many like operating system specifications are coming? If I click on this link, automatically here we are able to get Linux based Java software. For example, after selecting Mac, if I click on this one, automatically we are able to get what their Mac based Java software. After selecting this Windows, if I click on this one, automatically, right, what we are able to get there, Windows based Java software here we are getting. I think so. This is the latest version. That's why it is giving support for only few of them. Just I want to take like what the Java 8 version downloads. For example, now here I want to get it. All right, so now here I want to go for this. Okay, fine. New window, no problem. Now here what we are getting there. Now see this one, Linux based Java softwares. Next one is what there, Mac OS. Solaris related Java softwares. Windows based Java softwares. That means all the links are provided on the base of the operating systems or not? Providing links on the base of the operating systems in the sense. What's the meaning of it? No. What's the meaning of it? The meaning is like what there? Java software is a platform dependent or not? Very, very clear that the Java software is what there? Platform dependent. That we have to recognize clearly. All right, sir. It's okay, fine. Now this I want to close here. All right. This is exactly the meaning of like what there? Java software, and it's a platform dependent content. All right. It's okay, fine. Observe carefully. So the required points here we understood about this total content. That's okay. Now I have one important interview question, guys. Then everybody has to understand it. I will go for one important interview question. Observe carefully. Everybody has to understand it. What about my question here? Listen carefully. In this total discussion, we have .exe files, .class files. Now the question is, what are the differences between .exe file, .exe files and .class files? What are the various differences between these two now? We need to understand the differences clearly. The very first point is like what there. First of all, in which programming languages these are available? If you understand it, .exe files exist in C and C++, whereas .class files exist in Java. .exe files exist in C and C++. .class files exist in what there? Java. Point number 2. What they're having, .exe file is having what? .class file is having what? .exe file contains the directly executable code. .exe file contains directly executable code, whereas .class file contains bytecode. Bytecode. What it is actually? It is not a directly executable code. It is not a directly executable code, and it is an intermediate code. And it is what there? An intermediate code. .exe file contains the directly executable code, and .class file contains bytecode. It is not directly executable code, and it is an intermediate code. Next point is what? This next point is somewhat related with platform dependent and platform independent. .exe files are platform dependent files. Am I right or not? .exe files contains directly executable code which must have the local operating system representations. Means that they are platform dependent files. Whereas .class files are not, are .class files are the platform independent files. Platform independent files. Why? Because .class files contains bytecode. Bytecode is not representing any of the operating system representations. It's a neutral bytecode to every operating system. As per the requirement, later on we are converting that neutral code to some other operating system representation. That's a different one. But initially, .class file contains what there? Bytecode. That bytecode contains what nature there? Neutral nature. That neutral bytecode here we are getting clearly. Right, sir? Now this is one point, but one general point, general knowledge point, normal point here I'm telling there. In general, .exe files provides lesser security for the data. .exe files provides what security? Lesser security for the data. Alright, sir. Whereas .class files provides more security for the data. How, sir? How can we say that less security and more security? Alright, sir. Now understand it now. In two ways we can specify the security related content. What are the two ways to specify the security related things? No. First one is, all of you understand it, no? First one is C and C++ are lesser secured programming languages when compared with Java. Java is having more security when compared with C and C++. Obviously, .exe files are providing less security, .class files are providing more security. This is one reason separately. But another reason, in general, what is the point I'm telling there? In outside, if you observe this, majority of the viruses related softwares are provided through .exe files. But no virus related file is provided in the form of .class file. Think about it. So majority of the viruses are introduced through what? .exe files, but no virus is available with the .class file. Why? Because in Windows operating system, .exe file is directly executable file. Just if we touch it, automatically it's going to be executed. Automatically that virus is going to be introduced. But .class file is not like that. .class file is not directly executable code. I get my point or not? It is not directly executable. Even if you double click on it, it won't execute the code. No chances of introducing viruses in our systems. So .class files are providing more security for the data, whereas .exe files are providing less security for the data. Right. Now these are overall the differences here what we are having about the differences between .exe files and .class files. Now tell me, .exe files exist in C and C++, .class files exist in Java. .exe files contains directly executable code, whereas .class file contains bytecode. It is not directly executable code and it is not an intermediate code. .exe files are platform dependent files. .class files are the platform independent files. .exe files provides less security for the data. .class files provide more security for the data. That's it. Now this is exactly the content here what we are getting. Got it or not? Right, sir. That's okay, fine. This is completed. Now here we understood the differences between the third difference here we completed. C and C++ are platform dependent, whereas Java is what their platform independent. That point here we completed. Okay. Then tomorrow I want to go for some other content, some other difference here. The difference would be like what there pointers. Pointers are existed in C and C++, but pointers are not existed in Java. What exactly the reasons why pointers are not available in Java and pointers are existed in C and C++? That content we are going to understand. After that, multiple inheritance related content we are going to understand. Like this, we are having some content here now. Okay, right, sir. That's all. I want to stop here itself, and tomorrow I'll continue the class. Don't worry, don't miss the tomorrow's class also. Pointers is a somewhat interesting topic I'm going to discuss with you. Don't miss that content, right? Right, sir. That's all for today. We'll meet on tomorrow. Thank you. Thanks a lot.